Okay. Good afternoon, everybody, and welcome. My name is Silvana Masella. I'm the CEO of Trust IT Services and an SME out in Pisa. And it's a very hot day, so we still have summer, so we're very lucky. Thank you very much for taking the time and joining myself and a bunch of wonderful speakers for a 2-hour webinar. You can see on your screen, it's a combination of 2 CSA projects, all of 2 different units from DG Connect, funded by the European Commission. We have a Digital Europe program, CSA, called allpros.eu that supports the Secretariat for the Alliance on Semiconductors and Chips. And we have our project officer on the call as well of DG Connect, Thomas Reiber. And then the second CSA is the EU Cloud Edge IoT CSA. And we also have the project officer of DG Connect, Rolf Riemenschneider, the head of sector of IoT at the EC. So as we're unable to have all of you speaking, we do want to take advantage of the chat. So if you'd like to tell us who you are in the chat and what your expertise is, it's great to obviously grow the community and know who we have on here. And we're happy to get back to you on any questions that you want to ask after the webinar, and do feel free to use the Q&A that we have today. With the agenda, as I mentioned, who we have at the beginning, we're then going to walk through some market assessment and insights from our partners in both Allpros and EU Cloud Edge IoT from IDC. We then have some insights from Decision on semiconductors for edge computing and IoT, some use case pitches from Anastasios Nefeli and Inessa VDE with some edge AI innovations under the CHIPS Act. We'll move on to then a panel discussion with some of our representatives before, plus Patrick Paipi from NXP and Ovidio Vermessen from Sintef, to understand and look at some requirements of future chips for cloud edge IoT. So today's webinar comes at the point of the Draghi report, which was released yesterday, and I'm sure many of you have dipped into it, or if not, read the whole thing. One thing that took my, what's the word I'm looking for? One of the things he said yesterday was that by 2040, 2 million workers will be disappearing every year from the labor market. And that is clearly extremely worrying. You know, I always go to the barriers first in any report and then look at everything else. But clearly some links to what the Draghi report said yesterday and what's going to be discussed today. So that's incredibly timely. Just some insights today on who's here. There are 10 countries represented, over 80 registrants. This is the breakdown of who is around us. And like I said, do feel free in the chat to indicate who you are. We are recording this event, so we will be publishing the recording and the slides post-event. As we're not all sitting in the room, do react to the event, either with a clap or with a thumbs up. It does give us that sense of being in the same room and having a coffee with you all. And please do capitalize on the Q&A section. And with that, I would stop there and look forward to listening to you all in the next 2 hours. With that, I'm going to pass the floor to Thomas Reiber, as already anticipated, from DG Connect European Commission. Thomas, over to you. Thank you.
Yes, thank you, Silvana. Good afternoon, everybody. My name is Thomas Reiber. I'm here in the unit of microelectronics and photonics in DG Connect. And I'm the project officer of allpros.eu. From our side, this webinar is coming quite timely because this Unlock CI CSA is coming to a close. So we are quite keen to understand what came out of this of that work. As Silvana already mentioned, yesterday came this Draghi report, which takes our attention, and we are in the process of getting soon a new commission. So we're expecting a new commission early November, latest in early December. And so this will come in a new frame where we are looking for CHIPS Act 2.0. And so the webinar will give us some impetus from the policy side, what we will do in the future in that sense to increase actually our competitiveness, but also to reduce our dependency from other countries, which is quite important. As you know, most of the chips now coming from Taiwan. And with that, I give the floor to my colleague, Rolf Riemenschneider. Please.
Yeah, thanks, Thomas. Thanks so much. I'm Rolf Riemenschneider from the IoT unit. So we are coordinating effort under Horizon Europe Cluster 4 from cloud to edge to IoT. And indeed, the webinar is very timely. So I will share my slides and see how I do it the best way. There's the screen. All right, you should be able to see the slides now.
Not yet, Rolf?
Share now.
Yes, they're coming in now. Perfect. Yep.
Okay, I
Let's
think
see if that line goes. That's getting smaller.
Can I see the screen? Yeah.
Yes, you.
Yeah, okay. We have to stay with that. Okay, good. So the topic is decentralized intelligence at the edge, semiconductors in the world of AI, cloud, edge, and IoT. And as you mentioned, there's a Draghi report which is out. So I think, as Thomas mentioned, we are in the transition to the new commission to look at priorities for policy and R&I streams, to brief the commission and to give them guidance. And one of the key areas of collaboration will be competitiveness. IoT as a sector is not a vertical. We are very, very horizontal. We influence many other verticals, but we also have a value chain which is based and starting with the microelectronics and the semiconductors. So that's why the webinar is very timely and very important as well. Where do I go now? Where do I have that?
Next page. Scroll down.
Now it's going. So for this commission, we coined the digital CADE objective for the cloud edge IoT continuum. So what does it mean? On the first hand, you see the continuum from cloud, the cloud business, the hyperscaler business. At the same time, you see on the left side, the IoT devices, where we see more momentum in bringing data from IoT to devices together and leaving the data and aggregating information at the edge. So we talk about edge computing, which has advantage, in terms of real time, but also keeping data local in terms of security, and at the same time benefiting from integrating AI and intelligence, decentralized intelligence, at the point of interest where the information is generated. So having intelligence close to the point of action, close to the devices who generate the data. And there was a target of 10,000 edge nodes by 2030. I think by far it was not delivered. And it's very prominent in the Draghi report, that this is still a key element for you to keep competitiveness in the data economy. We know that the hyperscalers and cloud providers are very, very strong and dominating the area, but there's an opportunity, a window of opportunity to act and to gain strength in that area of edge nodes and edge business, which is close to the strength of European industry, of system integration, traditional industry, industrial industry. So key takeaway, yes, edge computing, yes, and a focus on in the industrial side. So again, you see, what is the challenge? The challenge is on the one hand to have this orchestration of IoT devices. On the left side, to keep the data local, to make sense out of the data and control of the IoT devices, and also to manage the life cycle of devices. On the left side, you have that strong momentum in the cloud infrastructure, also for processing LLMs, large AI algorithms, the learnings, and bring that learning and the AI intelligence to the edge, close to the point of action. So the edge is in the middle. It has an instrumental importance. So we have to talk about the continuum, the orchestration between the cloud and the edge, and the IoT and the edge. We need the orchestration of IoT devices and local decision making and decentralized intelligence. So that's basically the main element about it. What are the technology drivers at the horizon? I mentioned it, real-time response, because you're keeping the data local. You don't push data to cloud services around the world. You have more security because you're reducing the attack surface. You have to work as a new element for research and innovation on this orchestration. So where do you place the actions? Where do you do the computing? Where do you have the orchestration of the elements? And mostly as an innovation driver, we see that reasoning on the go, meaning integrating intelligence, AI at the edge and at the core, which has an impact for many application areas like energy, if you talk about energy aggregation, if you talk about automotive, connected cars, and so on and so forth. So basically, we see a lot of technology drive, and the question also of the driving report is how that is mapped to the industrial sectors. So how do we gain the economic benefit, create economic benefits out of that technology driver? We later on have a presentation from Decision and about the study, and they made a study about the value chain of from the bottom to the applications, and you see examples about different ways of how do you do edge computing. Either you have sort of what they call a thin edge about microcontrollers, but the momentum of innovation is definitely what they call a thick edge. So we call that name a thick edge, where you have a powerful computing integration with multi-cores, controllers, a system on chip, and definitely, you know, this system on chip will include elements of AI and an AI core, and you have a training and a learning and a decision making at the edge, and what they call the thick edge. So that is a bit of an opportunity for Europe, and we have to figure out, you know, how fast the ecosystems, the industry is able to capture that. So if the semiconductor industry invests into microelectronic semiconductors for the thick edge, who's taking that up? Do we get the critical mass? And you see that value chain over here, you know, the electronic components and the semiconductors are at the bottom. It's the starting point of the innovation chain, and it has to go all the way up to the applications. Otherwise, you know, we'll not create sufficiently demand for the semiconductors, because semiconductor fabs need to run at high speed and need to run at full potential. And if you don't have a sufficient demand side, it will not happen. You know, you will not be able to have an efficient fabrication of this new generation of chips. So there's a market push to CHIPS Act in Europe, for CHIPS Fab in Europe. It will benefit for more computing at the edge if it's needed and if it's exploited with the applications. We need novel architectures. We need virtualization of these complex computing infrastructures. We need containerization, dynamic allocation of allocations and decision making, and the future drivers in embedded AI. So we see growing demand side, and if you look at the Draghi report, here I quote, the innovation potential of mainstream chips in larger nodes, as well as chiplets to leverage EU strengths in established industry, e.g. the automotives and sensors for IoT and edge, is a key element, you know, to seize that innovation potential. And though that is the core of the workshop today, I think I hope I was able to set the scene, to keep that in mind, and be looking definitely at which are the most dynamic application areas, who are the industry to bring their stakes together and to agree sort of on an edge computing platform to create that demand. And if successful, you know, European semiconductor industry might be able to supply and to respond to that demand, or even lead the demand on a global basis, or create a European NVIDIA for industrial edge computing. So that's a big question mark. Are we able to have that speedy integration to ramp up the fabrication and create the demand side? So that will be the overriding question for today. And with that, you know, I leave you looking forward to a stimulating discussion. More information is on the portal, the EU portal, Cloud Edge IoT Continuum. And be reminded of the Unlock CI final workshop on the 23rd of September in Brussels. And that's all I wanted to say. Thanks so much and for your attention and wishing you stimulating discussions.
Thank you, Rolf. Thank you, Thomas. We are experiencing a few issues on the chat side that we're trying to resolve. So I'm not getting the questions in there, I'm afraid. But thanks for those insights, Rolf and Thomas. Huge challenges, talking about speed, supply, and the response to that in Europe. And with that, I think it's good to link this to our subsequent, our next intervention from Luis Fernandez, who's a senior research manager from IDC, where you have some future predictions in here, don't you? And on a market assessment. So I'll pass you the floor. Thank you, Luis.
Thank you. So hi everyone. Good afternoon. I hope you can hear me well, and you should be seeing my slides.
We can see those. All good, Luis. Thank you.
Fantastic. So I'm just going to give you a bit of an overview of how the market is evolving. Now we have some predictions, we have some data obviously already in place, and we have some predictions of what we expect to happen until the end of the decade. Obviously, more than that is a bit of futuristic thinking, but we can share with you at least until the end of the decade. So this is a graph with basically the market for semiconductors. This is worldwide, let me tell you. So what's happening here is that we had a bit of a slump, let's say, in 2023, much to do with inflation and a lot of geopolitical issues around the world, not just in Europe, but we had a bit of a slump. But the expectation is that it will start growing now in 2024 and is expected to grow at least, I have here on the graph, 2027, but we have some fresh data, not final, regarding 2028. And the expectation is that it will keep growing at least until 2028. So it's a huge market, becoming bigger by the minute. We expect it to reach the 1 trillion American trillion euros by 2030. And this should be an interesting market. As you can see here, the growth, although the growth is very big in 2024, then it drops a bit in terms of acceleration of that growth, but it will continue to grow notwithstanding. So that's our expectation. When it comes to the type of market for these semiconductors growing, as you can see here, this is another representation of the same graph, but basically it divides into industries. So a lot of the growth is coming from obviously AI. It's the word of the town and the word of the day, so it's impossible to run away from that. And I think the EU needs to, it's our assessment that the EU needs to work a little bit more on that and invest more on that. However, there's also growth around the industrial side and very specifically the automotive side, which are two huge markets for the EU already, notwithstanding the AI bit. So that's something to be important. And when you go the accumulated growth rate for all of these years, it's over 5%. Obviously, data center is the smallest one with 6%, but even the total market, it's over 5%. So it's an impressive growth compared to the obviously other markets that we could analyze. In terms of regions, this is something that we already know, right? This is both not just the fabs already built, but the ones being built or being announced in the past few years. And these should be unlocked until 2030. Now, we are growing as the EU, we are growing in terms of fabs. However, we're still at a deficit with other regions and other players in the world. So this is something to be taken into account, but there is huge investment in this area with the EU Chips Act, and there's a bunch of other programs parallel to that or adjacent to the Chips Act that are working to leverage this market. When we look at the technology nodes or the leading edge of these markets, looking at 2022, obviously Taiwan had a big influence, and South Korea as well, although not explicit, but this is South Korea. And we can see that in 2030, it's expected to be a bit more diverse. So please note that Taiwan will not lose capacity. It will just lose in terms of market share of the total market. The total market will increase substantially. So we expect those 70% or over 70% to actually become, even growing, will become less than 40% of the market. Now, the EU obviously is growing. It will have a big growth, but still will be expected to be after a couple of other regions, namely the US and obviously Taiwan, Korea as well. Almost neck and neck with Japan, but this obviously can change a lot in a decade. Now, over this next decade, we did mention the whole semiconductor side. So how are fabs going to evolve and grow, and the number of fabs that will exist moving forward. However, there's a few parts adjacent to the semiconductor side that need to be addressed. So we've had problems in the past, the pandemic, and after the pandemic, because of geopolitics, because of climate change, because of all these different factors, we've had issues with supply chains. These supply chains problems will be very important and will be something that need to be addressed, especially what we call the choke points. So the choke points can be specific, either geographical or political points in the globe, where for some reason, if something shuts down in that specific location, the whole supply chain gets affected. So we can think about things like geographical things, like, for example, the straits in Cairo, or straits, geographical straits, or specific components that exist in markets that are only built in a specific location. If something happens to that location, the whole supply chain becomes a problem. Also, the market will grow exponentially, as we've seen before, but these technologies are very interdependent with each other. So you can't build like a chip for networking without building the chip for compute. The chip for compute then necessarily needs the chip for storage. So there's a lot of interdependency of components and subcomponents, and this is something to be alert of in the future. Well, the third point is something we saw earlier, which is that it's expected to double in size in less than a decade. And obviously AI is going to have a preponderant role in this growth. So we're already seeing the disruption that AI is causing in IT in the EU. And we expect to see more of it as more companies are starting to experiment with AI, either by using it in pilots and other types of technologies, and some are actually implementing AI directly into production or already using in production. So when we look at those, we will need to address supply chain resilience. Like I said, we cannot depend on these choke points because they're very fragile and frail in terms of things happening to them. This innovation regarding the semiconductor industry has gone over for 60 years, sorry. but we need to keep innovating to keep the model growing. It's like it's a never-ending story where we need to evolve to be able to reap the benefits of that development being done before. Also, there's a huge problem with talent that we need to invest in. The silicon industry and this innovation core only works when it's growing, and it grows due to people and investments. And we have a problem with investments in talent, because the problem with investing in talent is that the repercussions take a long time to give you the benefits, right? If you start investing now, it's most likely you're only going to reap the benefits maybe in a decade or 2 decades. So it's a slow advance, but one that has to be done. And obviously, the tectonic shape that is AI that we mentioned will require more partnerships and will require an investment in the edge to be able to reap the whole package of benefits that AI might bring us. I'll conclude with that. Here are my contacts if any one of you would like to reach out afterwards the call. In the meantime, I'll be also in the call responding to questions in the chat if you'd like to ask something specific about the data or would like to hear more. Thank you.
Thank you very much, Luis. Let's give Luis a round of applause, and also to our EC officials before. I forgot to say that. So do use the emojis in the chat here below. Thank you for the timing as well, Luis. Some important future predictions there indeed. And in fact, your colleague Golbul, who's the project coordinator of EU Cloud Edge IoT, welcome Golbul. You're going to instead provide some insights on the intersection between Cloud Edge IoT and semiconductors. So we're happy to hear your thoughts on this. Over to you. And thank you to those of you, sorry, who are now writing in the chat, telling us who they are. It's great to know who you all are. Thank you.
Thank you, Silvana. I hope you can see my screen.
All good, yes.
Okay, perfect. So thank you very much and good afternoon, everyone. My name is Golbul Abdullahian from IDC, and as Silvana mentioned, the coordinator of Unlock CI project, which is one of the CSAs that now it's approaching its end in November under the EU Cloud Edge IoT. I'm going to provide you some insights that we generated, market insights in terms of computing continuum during the project, and also some, let's say, remarks in terms of the strong interlink that is there with the concept of semiconductors. But just before going to that, very quickly to some of you that might not be very familiar with the EU Cloud Edge IoT, I will explain to you very quickly that EU Cloud Edge IoT is a European Commission initiative that was established with the support of 2 CSAs, Open Continuum and Unlock CI, and it had the 3 main objectives of realizing a pathway for the understanding and development of the Cloud Edge IoT continuum, promoting cooperation and collaboration among the stakeholders of different stakeholders across the research, innovation, actions, and cluster projects, and supporting the definition and deployment of the large-scale pilots. And the Unlock CI as one of these CSAs is focused mainly in the last 2 years, more than 2 years, on the analysis of the demand side and bringing that into the supply side of the project clusters. Now, moving to the market insights of the Cloud Edge IoT and computing continuum. As you can see on the left side, we can see that the investment in Europe on all the 3 components of the computing continuum, so Cloud Edge IoT obviously is increasing, and the expected growth rate, compound annual growth rate for all the components shows a considerable growth across the computing continuum. Obviously, cloud is the most adopted technological part, and also it's not a surprise to see that the annual growth of cloud is still can be seen as bigger compared to the other components. But what is interesting here is that we can see is the considerable growth rate of edge. That it shows us that even though now currently edge is not very much adopted across industries in Europe, but the future forecast shows that it's going to be adopted, and it's going to be adopted a lot, and the investment will go through it a lot. So the forecast is that by 2027 there will be about 75 billion euros in Europe that will be invested in edge. And this will be across different industries. So you can see here on the right side that currently the industries that apply and deploy these technologies, the edge technology, are mainly manufacturing, energy, and healthcare. And some other sectors like agriculture and transportation and mobility are lagging behind. But again, the interesting observation that we can have here is that they plan to just recover this gap and adopt the solutions, the edge solutions, in the next 3 years with an interesting rate. So they are gonna cover the gap with the other industries that will be also pioneers to adopt the edge in the future. And obviously, when we talk about this move and shift towards the edge computing, we're talking about it at the use case level. So on the right side, you can see the spotlight use cases that we have identified based on different factors. It's based on the strategic relevance of these use cases, but also based on the adoption rate that they have, but most importantly, based on the forecast of the adoption of these edge use cases in the future. So as an example, for instance, on the left side of the slide, you can see the spotlight use cases for the manufacturing sector. So even though that we see that there are the use cases such as asset monitoring or visual inspection that are currently adopted to a good extent in manufacturing sector, there are some other use cases like automated guided vehicle that are not currently adopted a lot, but the forecast shows that it's going to be hugely diffused in manufacturing sector in future. And so this highlights that many of these use cases needs also processing at the edge, and some of the, based on the functionalities of the use cases, some processing at the edge, some processing at the cloud. So we are talking about a decentralization and a distributed computing. And here we come with the challenge of the orchestration across the computing continuum. Here you can see that that currently, and this shows the current status of these use cases that we were talking about, that the workload is distributed across the computing continuum from the cloud to edge, somehow in between. So maybe currently most of it is on cloud and some part of it is on edge. But what we expect is that in the future, in the next 5-6 years, there is a big shift towards the left side of the continuum, which is edge. So most of the processing and analysis will be done at the edge based on the results that we got from the market respondents on these use cases. And this brings me also to the point that also Luis mentioned about the next tectonic change that is coming. It has already arrived, but in the next 5-6 years, it's going to really be much, much bigger. So we are now at the level that we are seeing the effect of multiply effect of the innovation digitalization thanks to the new technologies that are being diffused, like AI, like Gen AI, large language models, and the diffusion of the AI at the edge. So what we expect is that we are more or less now here in the middle of this chart, and in the next 5 to 6 years, there will be a big shift towards the intelligent edge, which is gonna somehow define the industrial applications across Europe. And this means that there will be a big interlink also with the semiconductors industry, because when we talk about the AI at the edge, when we talk about the intelligent edge, we talk about the need for specific semiconductors and chips and the growing demand of them to be able to process and analyze the data at the edge. Here, for instance, you can see some forecasts about the generative AI across the industries in Europe. On the left side is the information about the companies that how much they think that they will exploit AI in the future and how much they are currently investing on exploitation of the AI at the pilot level. So you can see that more or less like half of the companies who just joined the survey, they participated the survey, they are dealing with this with Gen AI use cases. And then there is also a big part of them who will say that, yeah, we are going to make it to the next level. And the most, let's say, business areas that they are going to target with these Gen AI use cases are software development and product development. So again, this shift towards the AI at the edge, not only AI at the edge, but as one of the main drivers, highlights the interlink that the computing continuum will have in the future strongly with the industry of semiconductors. Just to wrap up some final remarks. So as mentioned before, our forecast is that over the next few years, the investment towards edge computing will see a very big growth, especially in industries such as automotive, energy, and smart cities, since they need, you know, the real-time decision-making and data analysis. AI-enabled edge devices will gain a big share of the market, linking a lot with the semiconductors market. This means that the demand for the semiconductors will be doubled, as Luis mentioned in his presentation. But this also shows a big question mark for Europe to understand that how we want to deal with this emerging and increasing demand of the semiconductors. And how Europe wants to position itself. Because in the meantime, when Europe putting lots of money on this and chips manufacturer, also other parts of the world are doing the same. So maybe looking at the value chain level could be something that might help. Then the need for upskilling and reskilling will arise not only in terms of the CI technologies, but also in terms of the complementary technologies such as AI and semiconductors. What is important here is to notice that when we talk about technologies, always we talk about the skills, but these are the interlinked skills. So these are things that should be done with a joint effort, at least at the European level for different types of technologies. And about security and privacy, it will remain a significant challenge for this paradigm shift, especially when we talk about AI in protecting AI models. And so this is something that semiconductor industry will need to embed in order to make sure that they bring the security when we talk about the AI chips. That's all from my side. Just as Rolf mentioned, I just want to inform you that we will have our final event, Unlock CI event, on 23rd of September in Brussels. So yeah, I will invite you to check the EU Cloud Edge IoT website to gain more information and register if you're interested. So that's all from my side. Thank you very much, Silvana, to you.
Lovely. Thank you, Golbul. And a round of applause to you for those two interesting insights, also from you, Luis. We're going over now to Leo, who's an associated consultant on Decision, who's going to provide us some insights. You want to already prepare your slides, Leo, whilst I introduce you on semiconductors for edge computing and IoT, thanks to a study that they carried out. Going back to the Draghi report, he keeps getting mentioned, but I wrote that he calls for doubling the EU's R&D budget to 200 billion euro and urging reforms, streamline bureaucracy, and then hoping to close the innovation gap with the US and China. So also this is food for thought on what investments could be made in the future if that really does take place. Over to you, Leo. These are coming in, I believe. And whilst you do that, we also thank you for the insights from yourselves. And I do believe, Olivier, you had some questions. So I'm going to actually post that and send it to everyone in the chat that we can maybe pick up after Leo's intervention. Okay, Olivier, Leo, over to you. Thank you.
Thank you, Silvana. Hello, everyone. So yes, I'm going to present you some findings, especially that are coming from a study that Decision has made with the DG Connect, the unit IoT. I guess the study ended 1 year ago, but it was a study on these paradigm shifts towards edge computing and the link with IoTs and professional IoTs, which are strengths of the EU industry. And the study also made the link with the semiconductor ecosystem, so we can have some food for thoughts in terms of opportunities and threats in the context of the EU Chips Act. So let's start with some key findings from this study. First message from what we are experiencing today overall is a paradigm shift from electronic systems to cloud-to-edge IoT platforms. What we call electronic systems, basically, to be very clear at the beginning, you have them here. So traditionally, Decision follows the production of electronic systems in the world, and they can be split into two types of electronic systems: consumer systems, which are composed of mobile phones, consumer PCs, audio and video applications, and home appliances. And on the other side, you have the professional electronic systems, which are composed of telecommunication infrastructures, professional servers, industrial electronics, automotive electronics, aerospace, defense, security, and health and care. So you have these traditionally distinction in terms of electronic systems in the world. And if I move to the next slide, first thing to have in mind in terms of background is that looking at what is driving the global electronics industry worldwide, you have here data for 2017 to 2022, but overall we have the same trend since around 2015 until today. That's the embedded electronics industries that are driving the growth of the global electronics systems, and not anymore the consumer systems, so consumer PCs and phones. So since around 2015, the leading segments of the global electronics industry are industrial electronics, automotive electronics, aerospace, defense, security, and telco infrastructures. You can see also health and care electronics with significant growth rates. Of course, you have the server segments, which is booming. And on the consumer side, you have some applications that are still driving some growth, like smartwatches or smart home applications. But overall, in terms of electronic systems, we are in a momentum where that's the embedded systems that are driving the growth, which is as such an opportunity for the European industry, because we are historically we have leaders in these systems, in these segments, as manufacturers of electronic systems. So you have here example of them: so Siemens, Continental, Philips, Bosch, Schneider, etc., etc. And so this is an opportunity for the EU as electronic systems. And now, because the question is on cloud to edge continuum. So from these electronic systems, what we are seeing for a couple of years now is that they are turning into connected objects, so IoTs, and now they are increasingly turning into cloud to edge IoT platforms. And so here you find back what we define as the cloud to edge continuum. So we have the micro edge data processing happening directly in the objects. So for instance, in the automotive industries, 15 years ago, we didn't have connected cars, so all the computing was happening in the edge, in the car. And now, as the cloud to edge continuum is being built, you have wide area networks, so electronic systems that are getting connected through wide area networks up to far edge nodes, so edge data centers, basically, and of course, hyperscalers, clouds, forming this edge continuum. And so this is affecting the traditional electronic system value chains. And in fact, before you had two value chains that were working in silos. So the cloud value chain, cloud and data centers value chain on the one hand, and on the other hand, the electronic systems value chain. And what we see now is that we have blurred lines between these two value chains. And when we talk about cloud-to-edge IoT platforms, it ranges from the electronic systems as such up to the far-edge nodes and the cloud computing side. And so here you have an illustrative slide with the representing the data that is being processed in the world in all these professional IoTs that we defined. And you can see the paradigm shift between data that were mostly processed only at the micro edge when most of these electronic systems were not connected. And as they are getting connected, most of the data, I mean, an increasing share of the data is being processed progressively in far-edge nodes and in the cloud. And at the same time, and I will move to that also, we have also a paradigm shift within the micro edge in terms of type of semiconductors, because looking again at professional IoT, before basically the processing was almost only done by microcontrollers and simple microcontrollers. And as we are moving forward and you see greater processing in professional IoT, we have new types of semiconductor system on chips and advanced processors, basically. So a shift from thin to thick computing. So we have these two paradigm shifts together, which make the situations more complex to deal with for electronic systems manufacturers, because they have to deal with these more complex value chains with a lot of newcomers. And you have here a list of key drivers of growth to master these complex cloud-to-edge IoT platforms. So open source solution, standardization, working towards interoperability, and co-design, co-implementations between industrials that are at various stage of the value chain. So in other words, we have an opportunity in the EU with the growth of these embedded electronic systems, but at the same time, as we are seeing the emergence of cloud-to-edge IoT platforms, it's difficult to keep up the pace from the technical point of view, and we have newcomers that are entering these value chains. So what are the implications for the EU semiconductor ecosystem? Basically, if I make the link, again, looking at embedded electronic systems, 20 years ago, processing in professional electronics was a question for microcontrollers. And so basically, these were the types of processors that were used for embedded electronics, basically. And so from the 2000 to 2015s, the momentum was rather what we call the golden age of microcontrollers. So we were seeing a growth of the semiconductor market in embedded electronics, but driven by volumes and volumes of microcontrollers, basically, which was good for the European industry, because we have world leaders in the manufacture of microcontrollers, with some competition from Japan and the US. And since overall 2015, what we are seeing with a move from thin to thick computing, so more advanced computing in embedded electronics, it requires new types of semiconductors, more complex system on chips, more advanced processors, and AI chips that are becoming important. And in this field, you have an historical strength of players from the US and Taiwan, which means higher competition for us. And they are entering the embedded electronics value chain. An illustration with automotive, between until the 2015s, the trend was the multiplication of microcontrollers per car on average, and the multiplication of electronic control units per car. And since 2015, what we are seeing is trends such as software-defined vehicles, EE architectures, with as a consequence, the rationalization of the number of microcontrollers per car, and central car units, which requires advanced processors. So you can see this shift in the automotive segments, And this leads to what we call here the battle of edge computing. You can see we've divided three types of computing that are required at the edge. And so we have thin computing, medium computing, and thick computing. And you can see on the left, so thin computing, basically that's standard microcontrollers with embedded memories. And in these fields, we have, as I said, leading players, Infineon, NXP, ST Microelectronics, some competitors, especially Renesas and Microchips. But the EU ecosystem is overall, and also rising competitors from China, by the way. But overall, the EU is still in a strong position, of course, in this field. And at the same time, at the edge, what we are seeing is the rising needs of medium and thick computing. And you can see thick computing, so basically that's advanced processors, you can have advanced AI chips. And here the leading players are Intel, also in the automotive segments with Mobileye, NVIDIA, Qualcomm, AMD, Samsung, and MediaTek. And in the level of thick computing, in the EU, the leading players is also NXP, also in line with the purchase a few years ago of Freescale. And in addition to NXP, Bosch is entering also the topic for a few years at the level of the design. And we have a pretty dynamic and strong ecosystem of startups and SMEs, more than 20 SMEs identified in this field. But for them, the challenge is to scale up, of course, with strong competition from especially the US. And in between, you have what we call medium computing, which is especially the trend for instance, manufacturers of microcontrollers. They have to try to expand the computing capacity at the edge while building more advanced system on chips with more advanced microcontrollers, 32, 64 bytes, with embedding AI software, some AI hardware as well, and so building more complex system on chips. And by the way, there is also a challenge for US players from the SiC edge, because for them, the difficulty is to understand the specificities of these new applications, for them, embedded applications. And so there are some constraints that they are not familiar with. And in hardware software orchestration as well, it's more difficult when you don't have an expertise on the application. So this is a bit the landscape at the semiconductor level. And if I summarize with some threats and opportunities, so this is a bit the big picture of what I've just mentioned. On the left, you have the global market of these cloud-to-edge professional IoT platforms. So basically, it encompasses automotive electronics and the various embedded segments that I mentioned. And you can see that we are experiencing in the world an impressive growth rates of these platforms. And at the same time, you can see inside the paradigm shifts with the rise of the cloud platforms and 5G platforms, and also the rise of the percentage of semiconductor for computing functions inside these platforms. And so on the right, you have an overview of this new competition with the traditional systems manufacturers, but which has to deal with the newcomers from the hyperscaler clouds at the level of cloud platforms and 5G platforms, and at the same time, newcomers from the semiconductor ecosystems coming from the processors side, especially, I mean, on the two sides, that's mostly US newcomers on the EU market. And so some overview of strengths and weaknesses for the EU. So as a strength, the EU still is a leading industry for automotive electronics systems, factory automation systems, health and care electronics, energy management systems. So we still have leading players, and this is an opportunity for us. We have key suppliers of semiconductors focused on thin computing initially, Infineon, NXP, ST, Bosch, not only them. And we have, I mentioned, an ecosystem of startups plus NXP also on the thick computing side. And we have also 5G equipment manufacturers, Ericsson and Nokia, which are also great assets. On the weakness, I mentioned them, semiconductor providers of thick computing semiconductors, 5G and 6G chipsets, also Qualcomm and MediaTek, hyperscaler cloud. And I think I will leave it for the panel discussion, but one of the challenge for the EU is the fragmentation of our ecosystems compared to the US and China, where we have large champions and integrated players. And it's a challenge for us to find ways to compete with these players all together. And that's it. Thanks for your attention. And you have here my contacts if you want to reach out to me.
Super, Leo. Thank you very much, especially the slides at the end. I do know we're picking up some requirements and tech needs indeed in the panel discussion later, which we've saved some slides for then. So that's extremely important. We're going to move on now to Anastasios Zafiropoulos of Nefel. Hello, Anastasios. Can you hear and see us? And you're going to give us some use case pitches, which is always great when we get this part and our hands dirty, you know, putting some words into practice. Over to you, Anastasios. Thank you.
Many thanks for the introduction. Hi to all also on my side. Okay, I'm coming from the National Technical University of Athens, and I'm the technical manager of the Nefele project that is actually belongs in the cluster of the projects that try to provide meta-orchestration solutions. That these solutions focus on how distributed applications can be deployed and managed over resources that span across the computing continuum. So we consider Internet of Things, edge and cloud computing resources. And I will try in this talk also to show the interlinkage that all these technologies have also and can take advantage from the evolution of the semiconductor industry. So just as an introductory part, just to say that in the Nefele project, we work on two main innovations. The first one that actually I will mostly focus also on this talk has to do with a software stack, an open source software stack that tries to tackle a lot of Internet of Things interoperability issues. So how we can virtualize IoT devices in a way that we can solve interoperability challenge, both communication protocol and semantic interoperability, but also convergence challenges, so convergence of IoT with edge and cloud computing infrastructure, so as at the end to be able to manage applications that can be deployed over different types of resources in the various parts of the continuum. And to do so, the second innovation has to do with a synergetic meta-orchestration framework that actually is responsible to manage this type of deployment. So in the project, we follow what we call a system of systems approach, where the overall responsibility is managed by a centralized entity. However, the control is distributed in different entities across the computing continuum. So it is of very high importance for us to take advantage of capabilities, node capabilities in the various parts, and also a lot in the IoT part. So advantages that can be brought by the semiconductors is very important to go on with modern infrastructure in the IoT part that can also support a lot the collaboration between the IoT and edge computing interplay. This is of major importance. In our case, we consider that for each IoT device, we have a virtual instance of it. We call it virtual object. So this acts as a virtual counterpart of the IoT device. And we have developed a set of abstractions to manage to have this as a software that can be executed at the edge part of the infrastructure. And where needed, we can have also composite virtual objects when we can have virtual objects coming from different IoT devices, okay, in the various use cases that can collaborate among each other so as to give an advanced functionality. So in the virtual object in short is called as VO, the composite virtual object as composite VO or CVO, and all of them together are under the development of a specific software stack called the O stack. An important thing to mention is that through this let's say, specification, we can also move on to the development of digital twins. So we can combine different type of VOS and CVOs to offer a digital twin functionality for the different industrial domains. This is the overall concept. So we have a different type of infrastructure across the computing continuum, starting from IoT devices, cluster of IoT devices, edge computing nodes that hosts also the virtual object and composite virtual object functionalities, and cloud computing nodes that host mostly the more, let's say, intensive, computational intensive or memory intensive application components. However, an important thing to say is that an application, a distributed application, can be represented in the form of an application graph, where you may have different application components, including virtual objects and composite virtual objects, all of them managed by a centralized entity. A specific software stack is developed for this purpose. I won't go into details now, just to say that we have different layers supporting the interaction between the edge device, the edge software, and the IoT devices for the communication part, the main business logic, and also the convergence part with the cloud part. And we have implemented this software stack based on two specifications. The one has to do with Open Mobile Alliance lightweight M2M, and the other one with the W3C Web of Things specification. So we have tried to be very much compatible with standardization and also follow evolution of the standards. An important thing to say that is also very important with regards to what the IoT devices can support, taking advantage of semiconductors technology, is that we can have different modes of interaction. On one side, the IoT devices can just act as sensing devices. So I sense specific environmental parameters and I move the data to the edge, or also as actuators. So I can give back commands, and these commands can be translated to actions by the device. So we foresee a strong interplay between what we call IoT virtualization and semiconductors, because we can see that in both cases, we can have benefits in the form of enablers for functionalities of the IoT devices by using advanced semiconductor-based sensors, so considering also system on chip that was mentioned. So this can help better sensing and data acquisition by proper conversion of data into electrical signals and their processing. Specific advanced processing and control by specific microcontrollers and microprocessors that can be powered by semiconductor technology. Also, the support of the actuation part. So by proper techniques, we can have the conversion of the electrical signals to actions supported by the IoT device. We can take advantage of the evolution of the different communication modules through chips, considering Wi-Fi, but also 5G, 6G technologies built using semiconductors. For sure, built-in security features related to encryption and secure boot capabilities. Low power consumption chips to increase as much as possible energy efficiency of the overall deployment. And as already mentioned, very important, the AI integration in the kind of neuromorphic chips, and also the alignment of such chips with the support of tiny ML approaches that can be executed in the IoT devices, but also interplay of ML workflows between parts of workflows that can be executed on the IoT and part of workflows that may be executed at the edge part. So this is also very challenging to facilitate scenarios where we may have resource constraints on one hand, but also low latency requirements. So we have to find a balance on where is executed what. And on the other side, there is also start increasing a trend about the adoption of digital twins also for the development of semiconductor in the semiconductor industry, considering a lot of challenges and complexity that has to be managed in the modeling of such systems. So this is something that also the evolution of IoT virtualization techniques can facilitate the semiconductor industry. This is the overall architectural approach that we follow, just to say that we have the virtual object stack covering requirements in the IoT domain, but then there is a lot of intelligence introduced in the meta orchestration part, where we have management of compute resources, but also network resources, and we consider the interplay of such resources. So once again, adoption of chips by recent releases, let's say, can also facilitate to have better guarantees in terms of performance and also latency in latency-strict, latency-sensitive applications. Now, coming to
Anastasios,
sorry,
so you'll have a few more minutes to get to your concluding statements, if you can, if that's okay.
Yes.
Lovely.
So,
thank you.
Coming to the use cases part, just to say that we work in 4 different use cases related to emergency and disaster recovery, remote healthcare, smart port, and energy management in smart buildings. And in all these cases, we have deployment of specific virtual objects by using different type of devices and chips to support the various functionalities. So I will be very short, just to say that we work on scenarios related to emergency and disaster recovery, where we have different type of robots and sensors, actually sensor carrying robots that try to navigate and do an autonomous exploration in an area. And we have the proper development of the virtualized part of their management. We have support of logistic operations in ports, and especially in the Luca-Koper port, where we also consider the custom development of specific IoT gateways and 5G infrastructure to support the deployment and the optimization of the overall routing process of the containers. We work a lot for energy management in smart buildings, where we have, again, custom IoT devices, in this case provided by Odins and Siemens, by following the development in the project to support energy efficient control and automation in smart buildings. And also in the healthcare domain, we support the decomposition and virtualization of ultrasound medical imaging systems into resources that can be offered by the continuum to support remote healthcare operations. Just to conclude, saying that in all cases, we have the development of the virtual objects, the interplay between them and the specific devices, and the overall orchestration stuff of the application graphs. And all of them are available as open source under the Eclipse Research Labs GitLab, where all this software is maintained. So many thanks.
Anastasios, thank you very much for that. Sorry, we had to speed you along. But before I move on to the final speech before the panel discussion, use case is always extremely important, right? In every single R&I project we've seen under Horizon Europe and non, and how effective they are and how impactful they are makes such a difference. Now, you gave a description of 4 of those, and without sort of putting you on the spot, but do you feel from the end user perspective for the take up of the results, are they all of the same level? Do you think some are stronger than others? Do you see the buy-in from the end users that they're definitely going to be adopting what Nefeli is coming out with? And are you also interacting with, and it's part of the MetaOS projects, right? And the whole issue around the clustering with other like-minded projects. But just to conclude, a few sentiments for the participants online on your analysis of how effective the use cases are in practical terms.
Yes, thank you very much for the question. I would say that we have, at this point of time, we have mostly progress with the energy management in smart building use case, considering that the colleagues and the companies there are very active in the Web of Things group. So we have a solution that is implemented in specific buildings of Siemens, and they have adopted the technology provided by NFL to improve automation. This is one thing. However, the last period, we also progress a lot with operations in other three use cases. A lot of challenges in the healthcare and the port operations, because we have strict operational environments where we have to respect a lot of constraints in terms of deployment and latencies to be achieved in the communication. However, once again, the solutions are developed, are adopted, and we are proceeding with the validation phase. And one last thing, just to say, because we have delivered an open source software stack, we have two open calls in the project where this technology is also validated. In the first open call, we expanded the use cases domain in different sectors related to haptic communications, agriculture, further scenarios related to energy management and other cases. And we envisage to further extend these application domains to more use cases with different type of challenges in the second open call.
Brilliant. Thank you very much for that response. Thank you.
Thank you.
And now we're over to Inessa Seifert. Hi, Inessa. Can you hear and see us? She's a senior consultant from VDI Innovation, and she's going to be looking at some edge AI innovations under the CHIPS Act. But I don't know if she's frozen, actually. Inessa, can you hear and see us? Hello? Yes.
Yes,
Please, we can see your screen's coming in.
Hello.
Yes, you are frozen,
Oh,
but
and,
we can. You're moving now.
You should
Yes,
see my.
it's in.
Okay.
Perfect. All right, you're ready to go. Thank you.
Thank you very much for inviting me. So I'm from VDI and I'm representing here EPOS, the European Association on Smart System Integration. And I will report how we work in our working groups and our HAI working group, and how we proceed, and maybe about the structure, how we contribute to the positioning papers and strategic research and innovation agendas, and which part these documents play under the CHIPS JU. So EPOS is the European Association leading the development and integration of intelligent and green smart systems, technologies, and solutions for sustainable society. And we have a mandate to support our members in defining research and development, innovation needs. And we have the hidden champions, smaller companies, but also huge companies like Bosch, Sensotech, and NXP and EST Microelectronics as our members and active members of our working groups that contribute to the research and innovation agendas. And so these are our activities. Our goal is to agree and define and contribute to the European research policies, and we are somehow strengthening and providing the voice of our community to interact with, of course, with other industry associations, but also with the European Commission. And what is important to say, we work together with other initiatives, for example, the CCAM and To Zero and Health Tech and the Transcontinuum Initiative, and many thanks to Ovidio, who invited us to computing. Continuum initiative. Am I right, Ovidio? So this is the initiative which was originated by HighPeak. So we're an active participant in all these initiatives, and we try to interact and provide our expertise and knowledge and understand the current trends. So how it works. So what is CHIPS Act? I think for the European Commission, this is not new. So I'm addressing the participants of this webinar who probably have not heard about that. So there are 3 pillars. Pillar 1, Chips for Europe. So this is where research, development, and innovation topics are situated. Pillar 2, security of supply. So these are design platforms and fabs. And pillar 3, monitoring and crisis response. So these are the activities regarding crisis coordination mechanisms, how to react and to secure the supply chains. So we are basically involved in research and development agendas and contributing with their expertise. And CHIPS JU involves 3 industry associations, INEAS, EPOS, and INSIGHT. And member states and the European Commission. And it is a very complex process where the topics, especially so-called focus topics, horizontal topics, are proposed for funding. And so that we have to negotiate with participating member states and the European Commission so that this call is approved and that consortia can be built and proposals can be submitted and projects funded. The baseline for the CHIPS JU calls is a specific document. So this is the Strategic Research and Innovation Agenda. And all the 3 associations contribute with their expertise to this document. And there are more than 300 experts who are contributing. And unfortunately, it is not easy to read sometimes because so many people are writing on this document. But this is a document that includes all the topics that are funded under CHIPS JU. And you can see on the website of CHIPS JU the references to specific parts of this document. How we work together with industry and research. So EPOS has specific groups, working groups, and these working groups work together on topics that they propose in form of positioning papers. And so that was, these are the goals that were defined in a HAI working group, and it is a joint working group where EPOS and INSIGHT work together. And the intention is to contribute with the results also to the SSC sphere. And this group is also advising the European Commission regarding the so-called horizontal focus topics. These are specific calls that are also funded in the scope of CHIPS JU. So I think it is a perfect link to these overviews, so where the innovation is taking place. And we can see AI accelerators are very important, and this is one of the topics that should be strengthened in the next years. We see also the connection to cloud computing. Of course, latency is crucial for development of these components. We see much innovation taking place in the area of memory controllers, network interfaces, and network controllers, and general purpose processors. Of course, we have a software layer with libraries, operating systems, resource constrained operating systems, memory virtualization, network virtualization, and of course, algorithms like time ML that should be able to run on these tiny devices. And as I already mentioned, all these things are included also in the current draft of strategic research and innovation agenda, which is now under revision. So we try to bridge the gap between components and product. And as we already see in various projects like Nefele, so that you mentioned, we see different components that are not yet real products and that need further development and definition of interfaces, tools to integrate all these components so that they really evolve and become a real product. So these steps need to be taken. And these overviews, as you can see, neuromorphic accelerators is a topic of HEI working group, deep exploration and development of neuromorphic technologies, especially spiking neuronal networks, AI-based hardware components, but also data-centric ML approaches, tiny ML. We have to deal with energy efficient machine learning algorithms and models that run on low power devices, of course, distributed computing, federated and robust AI models, and distributed processing along the computing continuum. And we have horizontal issues that are already partially solved or developed in the running KDT and ChipsDU projects. And now we're in conversation regarding AI-based engineering tools and automation, since what we observed, so there are very many labs where different chipsets and hardware with amazing results are produced and developed, but we're missing vocabulary, we're missing interconnection between the software developers, the hardware developers, and the engineers who integrate all these solutions so that the innovation takes place faster and the production will be cheaper, because the market adopts only technologies that are compatible and that are, well, cheap. You are very much welcome to join our groups. So there are different white papers that we already published and released. And so this is the structure of EPOS. You see, working groups are very important. And the benefits that you gain is just not only writing on long documents, and we try to keep them short, believe me, but also to meet same-minded people and discuss the geopolitical issues, discuss in a good atmosphere and safe environment about how different industry stakeholders and research institutions can cooperate with each other. And we share knowledge about the newest strategic agendas, roadmaps, also results from different trade fairs, and we share strategies that, for example, are followed by American government or Indian government, or not only the US, but also Mexico. And so we try to understand the overall picture and to share this knowledge in our group. So that's it. Thank you very much for the opportunity to present our activities. So these are the members of EPOS distributed in Europe. And if you need more information, just approach our EPOS office or me, myself, and thank you very much.
Thank you, Inessa. We can give Inessa a clap there. That would be great. Thank you for joining and giving up that overview. In fact, EPOS, together with NS and Inside, part of the 3A board, are we have regular contact within the remit of all pros. So we're quite familiar with the workings there. I do have a hand up from Yves Gigas. Hi, Yves. I'm going to allow you to...
Hello.
Yves, yes. Yves is head of programs from XLJU. We can hear and see you. How are you doing, Yves? Thank you for joining us this afternoon.
It's a pleasure. But I don't find my camera, to be honest. I don't know.
Yes, we can't see you, but we can hear you loud and clear.
Okay. Yeah, good. Well, I'm very happy to attend, and of course the CHIPS joint undertaking, as was explained before, has been in the last couple of years systematically looking at edge AI, either in the focus topics or in the either in the focus topics or in the general programs through the S3. I don't know what you want to hear from me, to be honest.
Sorry,
you raised your hand.
I didn't want to put you on the spot. I thought you had a hand raised.
No,
or you just wanted to
sorry, I didn't.
Clap, or
apologies,
I don't know, kind of...
No, I didn't. But I mean, I did find your your presentation interesting, or all the presentation interesting.
Okay, thank you so much, Yves, for staying on with us. That's great. All right. With that, then, thank you, Inessa, again. We are going to move into our panel discussion. So if I can ask Leo Saint-Martin from Decision, who you've already heard from, Patrick Piper, the Director from Strategic Partnerships of NXP, to put his video on. And we welcome also Ovidio Velmasan, who's a Chief Scientist from Syntef. Ovidio, can you see us and hear us?
Yes, I can see you and can hear you.
Right. I can't personally see you though. I don't know if it's just me. I can just see your background.
Maybe it's because the
let's
video,
see if you
you can see me now.
Not yet, but yes, we can see you now. Ovidio, that's great. Super. So this panel discussion, which sort of wraps up our second part of the webinar, looks to the requirements of future chips for cloud edge IoT. We want to sort of have a discussion, and participants are welcome to nip in with comments in the chat or questions, as we've been saying. They discuss the dependencies, and whilst I do that, we thought it would be a nice idea to have one of Leo's slides that I'll pass you the floor that you can already start putting that up whilst we talk, discussing dependencies and associated risks and resilience of the EU industry to new threats and opportunities. And so this is a part that considers opportunities and recommendations, and it's nice because we have different perspectives from industry, clearly from the research and academic part, and then decision from a consultancy perspective. So why don't we move? Do you have the next slide there, Leo? Indeed. So a first question for all of our panelists: the next specifications for chips in the cloud edge IoT. What types of chips to support in the EU? And why don't I start with you, Leo, as you provided this slide in the first place, and then I'll pass to Patrick and then a video.
Thank you, Silvana. So these again are some insights from past studies. So following my previous presentation and the different types of semiconductors that are behind the edge computing, we have several aspects to consider. If we look at our main strengths and considering the players that are coming from the microcontroller ecosystem, we have to find ways to support the emergence of what we call medium computing semiconductor solutions. So basically, you have examples here: system on chips based on more advanced microcontrollers. You have smart sensors. I mean, medium-sized microprocessors also are good enough, let's say, to provide many of edge computing solutions at the edge. You have the topic of chiplets, software orchestrations. So you have this first topic for us on the medium computing semiconductors, and there we have a strong ecosystem in the EU that can be supported here, and which answers many applications on the application side. And for these types of semiconductors, we do not need basically very advanced manufacturing capacities, and process nodes up to 22 nanometers are largely sufficient to propose such solutions. And at the same time, so this is the first point. And a second point is that from the output of the study we've made, the main market prospects for edge computing in industrial IoTs are the market prospects associated with thick computing, so the deployment of more advanced processors at the edge. And this is a more difficult question, I guess, for the EU, because we have to find ways to support the emergence of a strong EU ecosystem. And so far, as I said before, we have already NXP. In addition, we have an ecosystem of dynamic startups. And we have on the other side systems manufacturers which have very strong position on the global market. But here the question is more how to find ways to federate the ecosystem and to help support the building of an EU industry there, growing EU industry there, facing strong competition, especially from the US.
Thank you, Leo. Patrick, some thoughts on this? Oh, you're metallic. Yep. Mute and come back on. See if it's any better. No. It's the same problem as we had before. Yep. No. Okay, then whilst we get Patrick to sort the audio out, like, why don't I pass the question to Ovidio? Ovidio, over to you.
Yes, I think here we have to be in Europe a little bit more ambitious, because staying at 45 nanometer and 22 nanometer, it's not enough. These are all technologies they were introducing in production in 2011 and 2014. So the world is moving towards 2 nanometers and 1 nanometer technologies. So I think Europe has the capability to close the gap, because as you see in the report from Mario Draghi in figure 2, on Internet of Things, artificial intelligence, cybersecurity, cloud and edge computing, quantum computers, Europe is lagging behind. So without semiconductors and without advanced semiconductor technology, it's very difficult to catch up in these areas. So my point is that actually we have a huge opportunity with the CHIPS GU initiative and with the European CHIPS Act to reduce the gap in the next years.
Thank you, Video. Indeed. Patrick, let's look
Yes,
back
I
on.
hope
So,
the sound is better now.
it
Okay,
is.
perfect.
Yes.
So I would really agree with what is on the slide, and I would also like to give some figures on the automotive semiconductors market, because I think Europe is a key player in this. This market was almost $80 billion in 2023, and European players counted for 40% of that market, with NXP, Infineon, and ST taking 30% of that market. If you look to the automotive processor market, I think we can state, or it's in the market analysis reports, it clearly states that NXP, Infineon, and ST cover 45% of the market. And although most of the people see NVIDIA as a key player, and it is a key player, of course, in the market, they have less than 2% share in the automotive market. So therefore, my message is, let's not try to build a new NVIDIA in Europe, but let's continue where we are strong in. And this is exactly what is on the slide here. I think smart sensors, different types of controllers, and you talk about low, medium, high computing. But if you look to automotive processors, for example, there are always more and more computing capabilities, and they need to be extended with edge computing, AI technologies. So indeed, this is where Europe is strong in, the type of new developments of new architectures, new systems, next generation complex processors and systems. And that's where we should focus upon. And that will also help the other industries, because a lot of research in this automotive space is also valuable for industrial applications, for health, for energy, etc. One important element I would also like to add is, for example, the use of open source. And in fact, if we look, for example, RISC-V, there are massive investments in China and the US in order to build RISC-V-based processors. And here we cannot get behind in Europe. So it is important that also there, Europe is playing a major role in developing this type of new RISC-V-based complex processor architectures.
Yeah.
Thank you, Patrick. Ovidio, do you want to comment on that?
Yes, actually it's true on one sector, but we have to consider some of the trends that we see. We see that there is a push for more and more AI and edge AI accelerators. It's a push for generative AI in the different applications, and this requires a totally different approach to the semiconductors that have to be provided. And here I'm saying that we have to keep the pressure and the advancements in the semiconductor technologies. And we have to think that actually the semiconductor value chain has several components. You have design, you have fabrication, you have assembly, and you have electronic design, automation, and intellectual property. So Europe has to balance actually the investments and see how we can position in some of these areas. In some of the areas, we have a leading role, but in some of the areas, we are lagging behind, and we have to catch up because the industry is developing very fast, considering these new requirements from AI technologies.
Can I also react, Silvana?
Go, Leo, of course.
Yeah, because that's interesting. Just to complement, because I think we agree. I mean, we share the view that, of course, it's very important to keep up the pace and to support the EU in entering the more advanced processor sides associated with edge AI. But the point then is, from an industry perspective, what should be our priority? What leverage can we done to support the growing of the EU industry in this field? And as you said, you have the manufacturing side, you have the design side. And our point was also to say, on the manufacture of very advanced nodes, we know that the EU is lagging behind. So we have partnerships with foreign players, which is, of course, good, but it will be very, very challenging to keep up pace and to help emerge an EU players on the manufacturing sides of the very advanced nodes, while on the design sides of the very advanced nodes, in our opinion, it's more easier, and we have a room for opportunity because we have design capabilities in the EU. We have a strong R&D, we have key startups. And so maybe there is something to be done in priority also to support the design ecosystem in the EU of advanced processors linked with edge and edge AI.
This is a very good point because fabless design houses could be one area in which Europe can advance. Today, maybe US keeps 50% of this market, but here I think Europe has an advantage and can increase its market share.
And in fact, what we also see, in my opinion, is we are all global companies and we are working on a worldwide scale. And we see more and more investments from different players together in new technologies and also in design. If you look, for example, in Dresden, the TSMC fab, there is a co-investment from Infineon, NXP, Bosch in this. The same is happening, for example, in RISC-V, where Infineon, NXP, ST, and Bosch together with Nordic and Qualcomm invest in next generation RISC-V developments. So we will see more and more of this type of structures where partners are really working together. And that is, to me, one important element in the future. And this also needs to happen in the value chain, where people, end users, work together with semiconductor companies, with software developers, in order to define the systems of the future and the needs towards software and semiconductor developments.
Nice, nice. So if I can just pick up maybe, so Leo, you started it. You talked about, you know, a grouping. Well, you didn't say this. Don't want to put words in your mouth, but I'd like to. The Industrial Alliance is taking off, as we know, as part of that started back in 2020 with some working groups. And so in October, you'll be hearing more about 3E specifically around skills, PFAS and supply chains, with the idea that more working groups will be coming up, which is open to the members who supported this Industrial Alliance in the first place. This is coming back out. So Q4 2024, we'll be hearing more about this. A working group on the design ecosystem of advanced processors, pooling together. So I think you said that, Leo, but pooling together, Patrick, the organizations that you have cited plus more. So we're also talking about our niche SME or startups or mid-caps, why not? And bringing in, obviously, the part from the research side of IDEO that you work on. Could that be a viable gluing together of knowledge that could spike some good investments in the future?
I think this is a must to do to have this type of cooperation. And Ovidio and myself are working together already in a lot of R&I projects. I think this is important to have industry, RTOs, universities working together on research and also with other industrial players. But we also need to take next steps, and in order to bring the R&D to the market, to have the final innovation, there we also need to work together amongst industrial players.
Cited in the Draghi report as well, by the way. This is a connection more with VCs for the next step of commercialization. So let me run back a second.
One moment, just to mention. So we should not forget.
By the way, Ovidio, we don't have your video on. Did you want to put your video on or not?
Right, just a moment to see what is happening. Yes, I think you.
Yes,
can
you're
see
back.
So actually, what is important not to forget that ChiefGU has launched 4 pilot lines, and some of them are addressing advanced technologies, like, for example, 2 nanometer technologies that actually will bring us in a position to transfer these results to the industry. So I think we are on the right path. At the same time, we see that there are a lot of investments as well in design technology. And here the SMEs can take an advantage, because being a fabless design house, you don't need 200 or 300 people. You can manage as well with 50 to 100. And some examples in Europe of design houses show very good results from the SMEs.
That's really encouraging, Ovidio. Nice. Anyone want to say any other remarks about this particular point? Any of our other guest speakers? I don't know whether either Rolf or Thomas want to intervene on this specific topic. You're very welcome to. You don't need to put your hand up. If not, then do you have another slide, Leo? Did you want to say anything about this?
Yeah, if you want, I have just one other slide that's a bit the continuation of this discussion, if you want.
Go.
It's just to say, because if we once we have the point that we have these requirements to support design of advanced processors linked with edge AI in the EU, one of the question is how to federate the EU ecosystem to help build this, because one of the other issue that we have is the fragmentation of the EU ecosystem. And so we have to find ways to foster cooperation, co-design, co-implementation between EU players across the value chain. We mentioned already RISC-V, so the importance of open sources approaches and encouraging the development of industry standards, interoperability. But I think there is still something to be found here, maybe around the advancements from the first CHIPS Act on the federation of the EU ecosystem, including also the manufacturer of systems. And just to give two examples that we have spotted already in the past study, the example of Software Republic, which was a partnership in France between several players across the edge value chain, a partnership between STMicro, Thales, Renault, Dassault, and Orange. And another example from right now this year, there is also the building of the EU system-driven semiconductor initiative, aggregating several players, again, from various steps of the value chain, ARM, but also systems manufacturer, Airbus, Dassault, and startups, with the idea also to federate a semiconductor value chain with the system manufacturers, and working on common design platform, system-driven again, and so this topic. So that was just to continue the idea of how to federate the EU ecosystem to cope with the fact that we have a fragmentation of it.
Well, the way I see it is that you need different types of projects, and you have, I would say, projects with smaller consortia, typically industry, universities, RTOs, who develop some very specific technology or do some very specific IP development. But you also need, and that's the important part, projects with enough critical mass, where you bring together the key important players, for example, within a value chain, for example, working on open source developments. And this should be industry driven, but also with the presence of RTOs, of universities, and of course also with SMEs, who often can play a key role in a certain corner or in a certain development, and bring this together with enough critical mass, large size projects with real large ambitions. And I think this is the ambition level of these projects should further be increased, in my opinion.
Mm-hmm.
Just to follow up on what Patrick said related to open source, I think what we see is the emergence of open source hardware, open source software. We had it before, but now we have the open source AI that is coming. And for this, one element that is missing probably is the definition and the framework in which you can provide the open source AI. As AI combines the hardware, the software, the algorithms, and the data. And the complexity of this framework is increasing, and there is a need to have such an approach and definition of open source AI and AGI, which we are trying to provide with the project in which we are involved.
Nice, Ovidio. Comments to this? Okay. Just another question before we sort of wrap up and have a look at some of the key takeaways. One of the questions we wanted to sort of ask was, what kind of opportunities for SME industry collaborations that can further R&I in these fields are? We talked about the pilot lines within the CHIPS JU. Are there other opportunities out there that people aren't aware of that they can get involved in?
Yes, the competence centers. It's another very strong initiatives from CHIPS JU to build up a number of competence centers across Europe, which will be a huge opportunity for the SMEs to be involved in the ecosystem.
And for me, SMEs are very important also, and I think, Ovidio, you mentioned it already, for fabless design houses. I think they can be very creative in building new architectures, in contributing new IP to the floor, in building specific tools, for example, that help in analyzing systems. So SMEs have to find their niche, and that they can play an important role. And the big players are, of course, very happy to work together with them because they have that particular knowledge and they have that particular new IP. And as we all know, I think one of the key problems in Europe is the amount of technological skills and engineers. And if we have this type of SMEs with very specialized people, this can help to really come to a next level.
Indeed, Patrick. Lewis or Golb, I don't know if you wanted to add anything to these discussions that have just come out. If Lewis?
No, nothing on my side. I'm not sure if Golb would like to add something.
No, I think everyone was covered. Nothing from my side. Thank you.
Okay, so with that then, if you agree, can I ask either Nicola or Diego to show the key takeaways that we've been beavering to try and put down in some bullet format before we wrap up this webinar that we can go over, and then you can tell us if you if there's anything we've missed. So global market for chips will continue to grow massively, which is an opportunity for increasing EU market share. The interdependencies between semiconductors, HPC, cloud edge solutions are critical, and the value chain must address these connections to avoid supply crisis in aligning with the CHIPS Act's strategic goals. The rise of generative AI and the shift towards intelligent edge computing is accelerating, and semiconductors is at the heartbeat of processing vast data in sectors, as we've heard again and again, in manufacturing, healthcare, and energy. And then, well, I won't go through. So, yeah, the current manufacturing landscape for chips sees the an economic disadvantage. This can change as CI needs will expand due to the coming tectonic shift and EU's industry output matching the resulting demand. So today, EU has, we've all discussed that it has a good ecosystem, with well-established players and innovative SMEs, finding themselves competing for the design of thick computing semiconductors, supporting the ecosystem by developing, federating, and coordinating through a triple helix approach. This is something that was raised also in the blueprint in bridging the skills gap as part of a report by the skills working group within all pros, will be crucial to strengthen Europe's position. And then clearly we want to take away something concrete also. So in the latter part of the panel, we were discussing to which there seems to be a consensus around the future could be a working group set up within the Alliance on a design ecosystem of advanced processes. I liked some of you who were saying how there are some skilled SMEs in Europe who are extremely good at this, that can help be the glue with other more larger industries and research organizations, and bringing everyone together to then have this exchange of knowledge and intelligence is absolutely crucial. And I believe, Ovidio, it was you who suggested that this can all take place perhaps within the remit of the competence centers. We should also capitalize on the pilot line projects that are funded under the CHIPS JU. And then to avoid fragmentation, you need to prioritize open source solutions, hardware and software, leading to better interoperability among the value chain, not just manufacturers, but also users to define a common framework. And Ovidio, the part around OS, did we put that in? OS AI, we're missing a framework at the moment.
Yes, open source AI. So
open source AI.
We have to have a framework around this that combines the four elements. We have open source hardware, open source software, we have open source AI frameworks, but then we have to combine with data and have the framework for all these four elements.
Okay, thank you. So just maybe, a couple last words maybe to Patrick also and Leo for the panel discussion. Anything on here that you think really should be added, because it would be nice obviously to conclude these takeaways in a post-event report that could then be shared with everybody from the two projects with some concrete also actions going forward. And I think, let me just pick up before I pass to the floor, Rolf's reminding us in the chat, AI is a key innovation driver with potentially radical shifts in the value chain. Thank you, Rolf, for including that. I have a big black mark on the key takeaways, but I think we did go through. They've gone. Okay. Leo, sorry, or Patrick, any last thoughts as we're coming up to the hour? And I'd like to thank all of us. Let's give everyone a round of applause for the engaging and stimulating discussions. Never easy. We've had great interventions as well, and it's brilliant listening to all this intelligence going around on this webinar.
No, I think having this working group on design ecosystem of advanced processor is a very good idea, and if it can be made also in the idea of federate the ecosystem and involving system manufacturers, it would be very nice.
Exactly.
And one more invitation at the end from Patrick, Inessa, and myself. We invite you to the AGI conference in Sardinia, 21st to 23rd of October.
Lovely. Great place to be in October, I think. Are you able to add maybe the link here in the chat before we drop off? That would be great.
Yes, I will try. Just a moment.
All right. If not, then we can share it also on our channels. Okay. So with that, I wish you all a lovely Tuesday afternoon. Thank you so much again for our European Commission officers who stayed till the end. We appreciate that. We know you're all extremely busy. You're all extremely busy, but important discussions in light of not only the Draghi report, but it's nice also to take away something concrete. So I do appreciate the thinking behind that and not just scratching the surface of these topics. Thanks once again to everyone. Have a lovely afternoon until the next webinar. Thank you once again. Bye-bye, everyone.
Thank you. Bye.
Thank you.